Okay, hi everybody. So this is an SEM that stands for scanning electron microscopes. So there's probably the most common microscope you've heard of is an optical microscope where you're looking at magnified things with light, like visible light. But visible light has a pretty large wavelength, so that's really limiting on like how small of a thing you can see on your sample. So with electron microscope, we use electrons to look at samples, and because electrons have a lot smaller of a wavelength, you can see a lot higher resolution. So you can see small things that you normally cannot see even with an optical microscope. So yeah, this is what it looks like. So over here on the top left, you can see an image of a weld, and you can see like the scale bar over here is 500 microns, so that's like
so tiny.
Yeah, okay, that's like 1 millimeter. So it's pretty small. So that's like a weld. It's hard to tell here, but you can see different grains in your metal.
Also, what we can do is we can zoom in more if we want to. For instance, here there's like these little pores, and if we zoom in more, we can see basically inside of them.
Wow.
So that scale bar right now is 40 microns. So 1 micron is, or I guess in 1 meter, there is 10 to the power of 6 microns. So that's a million. Basically a millionth of a meter is that scale right there. Yeah. That's a million right there. Wait,
yeah. Oh, yeah.
Okay.
If that looks familiar, it's because it's the same eyepiece as you'd use in an optical microscope, but the rest is different.
Alright, so this is a Raman microscope, and essentially you shine a single wavelength laser. So that's basically a laser that's just red or just blue or just green, and depending on how the light bounces back from your sample material, you can kind of figure out what type of bonds are in it. And from figuring out what type of bonds are in it, you can figure out what the exact material is. So it kind of acts like a fingerprint for different materials. And the lasers are back here. These are the 3 laser boxes. This is a AFM that stands for atomic force microscopy. And so essentially how it works is you have a needle that's super thin, like on the nanometers level of thin, and you use that needle and you drag it across the surface, and so your surface has like a force field around it, and it'll repel the needle or attract the needle, and from that you can get a resolution. So like you can almost, if you get a really nice sample, it is possible to see individual atoms, and that's honestly what I think is the coolest part. But other than that, you can get information about like how the forces and like attraction, repulsion of different materials from each other, and you can get like surface information from it as well. So it's very cool. So yeah, there's 3 different techniques of how you can see things differently. One using electrons, one using visible wavelength, and one using a tiny needle, and they all give you similar information.